So today we're going to be thinking about distance time graphs. Oh, excuse me. So let's think about a graph like this. So we'll often want to plot the motion of something moving away from a certain point. So on the x-axis we'll have time, and on the y-axis we have distance. So say we've got something like this. So as time is increasing, the distance from this point is going up. So you can see this indicates motion. If it's a straight line, the motion is at a constant speed. And if you were to calculate the gradient of this line, and just in the same way as we did when we were doing line graphs, you would give us the speed. So the speed equals the gradient of the distance time graph. Now, if we now have a period of time, the distance isn't changing. We're still at the same distance away from this central point. So this shows us for a period of time the object is basically standing still, isn't moving at all. And then after another period of time, the object moves again at a steady speed. The gradient is constant, it's a straight line, and then the object stops for another period of time, and then if we go down, this indicates when the object is moving back towards the starting point. So the distance here is the same as the distance here. So we've moved away and now we've moved back. And this is a very basic distance time graph, and being able to interpret the motion of this object is really helpful. Now if we were to have, now I'm going to just draw on the same one, I'll change the colour actually just to make it, so if we had something like that, and then so this has a shallower gradient than this one. That indicates the speed is going to be slower than the speed of this object. Again, we've got a period of rest, and then we've got some movement. The movement is going to be quicker than it was at the beginning, and again then we've got this quick movement back to the starting point. Let's look at an example. So the boy, and he's walking home from a bicycle shop. So he's going home, we'll just keep with the red, home from a shop. He spends 20 minutes choosing a bike, then he walks home to a bicycle, then he goes home. Constant speed of 9.6 kilometers per hour. And then we've got this graph. Now it's not going to be, when you're given these graphs, they'll be done on graph paper. If you have to draw one, you'll do it on graph paper. So I'm just going to draw the rough outline. So this is time, and this is distance in meters, and this bit here is 800 this bit here is 1015. Oh, it's the time day. It's the time. And he starts walking at 10 o'clock, and at, wait a minute, I should have taken this too far. Pencil, and he stops here at 10:35. It's going to be a 3. Okay, find the distance from his home to the shop. So distance to his home, from home to shop. So let's look at the vertical scale. So this line here is when he stops and he's in the shop. So we're thinking the distance is going from here for his home to here. It's going to be 800 meters. You just read it off the graph. Next is find speed from his home to shop. So for this, we need to calculate the gradient. So he walks in the 15 minutes, 15 minutes, he walks 800 meters. So which means in 30 minutes, he would walk 1600 meters, and then in 60 minutes we double it again, that would be 3,200 meters. So therefore his speed is 3.2 kilometers per hour. When does he arrive home? So we know he walked, his return speed was 9.6 kilometers per hour. So in 60 minutes, therefore in 60 minutes he walks 9,600 meters. And 30 minutes, we'll write it as minutes so it doesn't confuse between minutes and meters. So we're going to half that, so that would be 4,800 meters, and in 10 minutes, so we divide that down by 3, it would be 1,600 meters, and half that again, so in 5 minutes it would be 800 meters. Now, if I was to, I think the simpler way of doing this is using the speed time formula. So speed is distance over time. For these kind of sums, I would memorize that and work them out accordingly. I think it's a far better way of doing it than all this. This is the physicist way of doing it, and I'm not sure why they're not teaching it in this textbook. So the last thing we want to do is complete the graph. Now let's see what we've got so far. We've got him going from his home to the shop. We've got him spending 20 minutes in the shop. And we now know it's going to be 5 minutes for him to get home. So that's going to be up to here, 10:40. Let's write it here. And so we just join the dots. So you can see he gets home much quicker on his nice new bike than he did when he walked. So there you go. I hope that helps. I think I'm actually going to show you how to do I'm going to show you how to do this with this one here with this calculation. So we know the speed. We're going to do it in meters because it's going to be in meters. Okay, so we do the speed is 9,600 meters. We want the distance. Oh, we know the distance, sorry. We know the distance that he has to travel is the 800 meters back to his home, and it's a time that we want. So the time is going to be 800 divided by 9. Oh, I'm running out of space there. Divided by the 9600, and work that all out. You'll get a time which is in hours, and you need to convert it into minutes by multiplying it by 60, and then you would get the 5 minutes, which I think is a far better way of doing it. So I hope that helps.